Hello friends, this is Shivam and you are watching the next tutorial of the data analysis using Python series. And in this tutorial we will be exploring the classification algorithm of machine learning, and the data set that we will be using in this tutorial is the PIMA Indian Diabetes dataset, which is the data from UCI machine learning repository. And the task for this tutorial is to predict whether a patient has diabetes or not, and to see that to accomplish that task we will be using the logistic regression as a classification algorithm. So first of all, what we need to do is to import the necessary libraries that we will be using in this, and we imported the pandas library and the OS library, and then we just changed the work directory to the desktop where the data is needed. Since the data that we downloaded, it doesn't have the column name, so we just provided the column names. And then let's run this cell, and in the next step what we just read the CSV file using the pandas command, and we just provided the names as the column names, and we just said that the headers are not present in the data set, and we have just the names as the column names. So let us now see the first few observations of the data set. Now this is the data set, and we have the 1 2 3 4 5 6 7 and 8 number of observations, which are the predictors for the label variable. The label variable here, 1 represents that the patient has diabetes, and the 0 represents that the patient doesn't has diabetes. So describing the data, what we can understand is that that the pregnant here represents the number of times the person is pregnant or whatever it is, and the plasma glucose concentration is the glucose variable over here. This is the blood pressure, this is the skin thickness, this is the insulin concentration, this is the body mass index of that individual, and this is the diabetes pedigree function, whatever it is, and this is the age, and this is the label. The label is the target variable over here. So this is the data description. Now let's move ahead. Now to print the graphics within the same line, within the same cell, we just used the matplotlib line command, and we just also imported the seaborn package, and then we just try to visualize the statistical relation, the correlation between these variables using a pair plot function, using a pair plot. So and we adjusted the figure size. We have already done these things before in the previous lectures. So let us see now what is the statistical relationship between all of these variables and this one variable. So let's see. So I think the data is quite large, but not that much large. It is taking a bit of time, and yeah, here it is. So this is the pair plot, and it is used for statistical analysis and to see the various relationship between the various, because it has the x and y axis as the labels, and you can see that how the variables are related to each other. All of the data is distributed, and no variable seems to be so much correlated with each other. But let's move ahead. So the next step would be the splitting of data. First of all, we will define the feature columns, and based on that feature columns we will just create the data frame and the target column. So we have defined the feature columns, and these are the feature columns that we are considering, and this is the x and y data. Now the next step is to split the data set into test and train data set. So we will have to import the train test split function from the sklearn dot cross validation, and after that we will just use the same approach to split the data into the xtrain, xtest, ytrain and ytest data frames. So let us run this command and see. So we have just split our data set, and now let us see what is the shape of all of these different data sets. Now you can see that the xtrain dataset has 576 observations and it has 8 columns, and the xtest and ytest, these have 192 observations. So now let's move ahead and use the logistic regression. So to build the logistic regression, we will be needing the so let's move ahead. Now we will use the logistic regression log reg logistic regression as the logistic control Z. So here we will be, first of all we will have to import it. So let us type this thing over here. Now the next step is to build a logistic regression model, and for that we will be just importing the logistic regression model from sklearn dot linear models import logistic regression. We need to change this thing over here from sklearn linear model import. Now we will be just building a logistic regression over here. So log reg is equal to logistic regression. We are just trying to instantiate this model, and logistic regression. So now we will just fit a training data set to the log reg model. Log reg dot fit log reg dot fit, and we will just fit the x train comma y train. So this is the logistic regression model that we are just building, and we are just fitting the training data to the logistic regression model. So let's fit it. So now you see that these are the parameters that the logistic regression assumed itself. C value to be 1.0, and it used the solver to be lib linear, and you can see the penalty is L2 and the verbose are 0, which are the default parameters. So now let's see the prediction of the logistic regression model. Y pred class. Now we will be just predicting the test data set based on this model, and we will just test the x test data. So we have to predict. Now in the next step, what will we do is we will import the matrix from sklearn package. From sklearn import matrix, and we will just see the accuracy score between print the matrix dot accuracy score of y y test comma y pred plus. So now let's see what is the accuracy score of the model that we just built. So here we can see that the accuracy of the model is 0.78%. Is 0.78%. It is not that good, but it is quite a good model, we can say that. So now let's try to. So here we just add a comment calculating the accuracy score. Now we will just print the confusion matrix. So confusion matrix. To print the confusion matrix, we need to print and do the following command: matrix dot confusion matrix, and we need to give the same parameter over here as well: y test comma y pred plus. So let's see what is the confusion matrix. And here we can see that 110 and 40, these are the right predictions, and on the other hand the 29 and 13, these are the wrong predictions. So now let's see the ROC curve for it. So we will be printing the ROC curve and EUC, or area under the curve. Area under the curve. Now first of all we need to, we have the matplotlib inline command already, and now we will import matplotlib dot pyplot as plt, and we will just, first of all we will just have to predict we will have to store the prediction. We will have to store the predicted probabilities. To do so, we just need to y pred probabilities to be log reg dot predict proba, and we just need to give it the xtest command, xtest data, and we will just predict the probabilities for just class 1. So let's do it and store it, and here we have done it. And now what we will be doing is, we will be, in the next step, we will calculate the FPR, false positive rate, the TPR, and we will also give the threshold. By default the value of thresholds is 0.5, so we will give it the threshold. And matrix dot ROC curve, and we will give the y test comma y pred probe. So in the next step, what we will do is plt dot plot FPR. We are just in the ROC curve. What we just do, we just plot a curve between the true positive rate, which is the sensitivity, and the false positive rate, which is the specificity. So we will just try to, and the more the area under the curve of ROC curve, the more the value of the area under the curve, the greater the model is. So we will just plot the ROC curve, and now we just need to give it the two input parameter FPR and TPR. So in the next step, what we need to do is we need to define the x limit to be between 0 to be between 0.0, 1.0. In the same way, we will be just need to define the y limit to be between 0 and 1. Now we will just give the plot title to be ROC curve for diabetes prediction, and we will just give the x label as and we will also give the y label So we will give the x label as the false positive rate, or false positive rate, and we will give the y label to be true positive rate, true positive rate. Now we just need to we can also just use the grid lines for the plot, plt dot grid to be true. So that's it. Let's visualize the ROC curve. So this is the ROC curve, and we have just created it, and you can see that the area under the curve is quite well, because the accuracy was quite good, around 78%. And you can see that ROC curve, they help us to choose a threshold or a balance of sensitivity, and these are very helpful in a particular context, and these are we can say that for any kind of classifier, this AUC or ROC curve is very useful for the single number summary for its performance. So it is also helpful in generating the accuracy. So higher the AUC or ROC curve value, the greater the accuracy of the model is. So now let us just try to print the ROC AUC score. So matrix dot ROC AUC score, and we will just give it the y test, y bread probe, and let's see what is the score for it. You can see that 0.83. So we can say that it is quite a good score, and we have just built a good classifier with the help of logistic regression. So this was the basic model building, a classifier based on logistic regression to classify whether the patient has diabetes or not. So these are the machine learning implementation of classification. You see how we did it, and so I hope you understand from this lecture, and please subscribe, and thanks for watching.